Welcome to the deep dive. Today, we're going to be tackling a coding challenge
Oh, fun.
from AI.Code.Cast
Okay.
that,
Yeah.
really makes you think about efficiency and how to code elegantly.
Right.
You know how they
Yeah.
throw out those daily brain ticklers? Well, this one is all about adding spaces to a string,
Okay.
but not just randomly.
Yeah.
We're talking about placing them very strategically based on
Mm-hmm.
specific indices.
I like that.
What's intriguing is
Yeah.
it's not just about adding spaces, it's about doing it in the most efficient way possible.
For sure.
The challenge lies
Yeah.
in the algorithm, not the concept itself.
Totally.
Right. It's like you could probably come up with a way to do it, but if your
Mm-hmm.
code bogs down with a super long string,
Yeah.
you haven't really solved it elegantly.
Right.
So
Yeah.
what are we dealing with exactly?
So imagine you have a string like enjoy your coffee,
Classic.
a classic. You're also given an array of indices.
Okay.
Let's say 5, 9.
Okay.
Your mission, should you choose to accept it, is to add spaces into that string right before the characters
Okay.
at those indices.
Yeah.
So in this case, the output would be enjoy your coffee.
Makes sense.
Simple enough to do by hand, but how do we make a computer do it
Yeah.
without writing clunky code?
Right. Exactly. And that's where things get interesting.
For sure.
Before we jump into the elegant solutions,
Right.
let's talk about what not to do.
The do bots.
Yeah, the first thing that might come to mind is just splitting the string at each index,
Right.
adding a space,
Yep.
and then gluing it all back together.
Yeah. The scissors and tape method.
Yeah.
But that gets really messy and inefficient.
That's very
Especially with longer strings.
Yeah.
Every time you split and concatenate,
Right.
you're creating new string objects, which eats up time and memory.
And that's where understanding different approaches and data structures becomes key.
Absolutely.
Totally. So
Okay.
before we dive into those,
Okay.
are there any common gotchas or questions people might have about the problem itself?
Absolutely. One question that comes up is,
Yeah.
can the spaces array be empty? And the answer is yes. If it is, you simply return the original string.
Okay.
No modifications needed.
Makes sense. Another one is, what happens if an index in the spaces array is 0?
Good question. In that case, we add a space right at the beginning of the string.
At the very beginning.
So if our spaces array was 0, 5, 9,
Yeah.
our output would be enjoy your coffee.
Interesting. So those are some things to keep in mind.
Mm-hmm.
But now let's get to the good stuff.
Okay.
The efficient solutions.
Yeah.
Any hints to get our brains going?
All right. Here's your first hint. Think about building, not breaking.
Okay.
Instead of constantly breaking up the string,
Right.
what if we thought about constructing the final string
Okay.
piece by piece?
Ooh, interesting. So instead of constantly taking apart the string, we're building the new spaced out version from scratch.
Precisely. Now, to help you with this building mentality, here's hint number 2. Okay. Remember the power of string builders.
String builders. I do love a good string builder.
Right.
Aren't those designed to make string construction super efficient?
You could say that. A string builder is like a special container specifically for building up strings.
Okay.
You can add characters and spaces to it without creating a ton of new string objects every time.
So it's like we're avoiding all those messy string manipulations by using a tool specifically designed for the job.
Exactly. And here's why that matters. Every time you use the plus operator to concatenate strings, you're essentially creating a new object.
Right.
And that takes time and memory.
Oh,
With the string builder, you're modifying one object directly, which is way more efficient.
it's like the difference between building a house brick by brick versus trying to reshape a pre-made one.
Yeah, I like that.
Okay, so string builders are definitely on the table.
Right.
What else could we use?
There's another technique that works really well for this problem.
Okay,
The two-pointer approach.
2 pointers. Okay, I'm intrigued.
Yeah.
How does that work?
Imagine you have 2 people working together
Okay.
to add those spaces.
Right.
One person is reading through the original string,
Okay,
and the other person has the list of indices
got it.
where spaces need to go.
Okay, I'm visualizing it. One person calls out the characters. The other is listening for when to shout, space.
Exactly. You have one pointer keeping track of your position in the original string.
Okay,
Let's call it the string index.
that's string index.
And another pointer, maybe we call it space index,
Okay,
keeping track of the current space index from our array.
got it.
Right. So as you move through the string, you're constantly checking, is my current string index equal to the value at my space index?
Okay.
And if it is, bam. add a space.
You got it.
And you would increment both pointers.
Okay.
One for the next character
Right.
and one for the next space index.
Okay, so it's like these 2 pointers are doing a synchronized dance,
I like that.
making sure those spaces get added in exactly the right spots.
That's a fantastic way to put it. And it's
Yeah.
very efficient because you're only going through the string one time.
I love it. But I'm wondering if there's any other way to do this.
Okay.
We've talked about string builders.
Mhm.
We've talked about 2 pointers.
Yeah.
What if we wanted to get even more efficient?
Well, if you're feeling adventurous,
Yeah.
we can go a little closer to the metal
Okay.
and work with character arrays directly.
Ooh, character arrays. Now we're talking.
All right.
I'm always up for a challenge.
Let's do it. Working with character arrays directly can give you some serious performance gains.
Okay, so how do we approach this problem using character arrays? What's the game plan?
First, you'd pre-allocate a character array that's big enough to hold the final string.
Okay.
Remember that final string will be the original string's length plus the number of spaces.
Okay, so we're making sure we have enough room from the start, just like we did with the string builder.
Precisely. Now, you'll need 2 pointers again, but this time they'll be working with the character array. One will keep track of where you are in the original string,
Got it.
and the other will keep track of where you are in the character array as you build up the final string.
Got it. So we're copying over characters from the original string to the array, and along the way, we're strategically inserting spaces.
Exactly. As you move through the original string, you check if your current position matches a space index.
Okay.
If it does, add a space to your character array and increment your space index pointer.
And if it doesn't match, you just copy the character over to the array.
You've got it. Once you've gone through the entire original string, your character array will contain the final string, spaces, and all.
And then we just convert that character array back into a regular string, and we're done. That sounds pretty efficient.
It is. Working with character arrays directly lets you manipulate the memory where the characters are stored, so it can be really fast.
So it's like choosing between different levels of control, right? String builders are efficient and easy to use. 2 pointers are great for navigating multiple things at once. And character arrays give you ultimate control for squeezing out every bit of performance.
That's a great way to think about it. The best approach really depends on what you're trying to achieve and how much control you need.
This is already making my coding brain tingle. I'm ready to dive deeper into each of these approaches and see how they work in action.
Let's do it.
Okay, let's walk through a concrete example to really see these approaches in action.
Okay.
We'll stick with enjoy your coffee
Okay.
and our spaces array 5, 9.
Sounds good to me. So if we were going the string builder route, we'd start by creating a string builder
Right.
with an estimated size, right?
Exactly. Our original string is 15 characters long, plus 2 spaces.
Right.
So we could initialize our string builder with a capacity of 17.
Okay, so we've got our string builder prepped and ready.
Yes.
What's the next step?
Well, we need a variable to keep track of our position in the spaces array.
Right.
Let's call it space index, and set it to 0 so it points to the first space we need to add.
Got it. Space index is locked and loaded.
Yeah.
Now we loop through each character in the string. Enjoy your coffee.
Okay, so we're going character by character,
Yep.
checking if our position matches a value in our space index.
Precisely. So for the first character, E,
Right.
a position is 0. That
Yeah.
doesn't match our space index of 5.
Right.
So we simply add E to our string builder.
Makes sense. And we do the same for N, J, O, and Y.
Yep.
Just add them straight to the string builder since their positions don't match 5.
Exactly. We're basically building up the new string character by character and only adding a space when our position lines up with a value in our spaces array.
So when we hit Y at position 5,
Yes,
that's when things get interesting.
you got it. Since 5 matches our current space index,
Right.
we first add a space to the string builder,
Okay.
and then we add the Y.
Okay.
We also need to increment our space index to 1.
Okay.
So it's now pointing to the next space we need to add, which is 9.
Okay, I'm seeing the pattern here. We keep adding characters, and when we hit a position that matches our space index, we add a space first,
Yes.
then the character, and bump up the space index.
Precisely. We cruise through the rest of the string,
Okay.
adding O, U, R, and C since they don't match 9.
Right.
Then when we get to O at position 9, it's space-time again.
We add the space, then the O, and increment space index.
Right.
Though it doesn't really matter in this case since we've hit the end of our spaces array.
Right.
Yeah.
We've added all the spaces we need to add.
Right.
Now we just tack on the remaining characters, F, F, E, and E.
And at the end, our string builder holds, enjoy your coffee.
Easy peasy.
C. String builders are pretty handy for this kind of thing. But let's switch gears and see how the two-pointer approach would tackle this.
Okay, so with two pointers, we don't have a string builder, right?
Right.
So how are we storing the result as we go along?
We create an empty string.
Okay.
Let's call it result,
Okay.
and add to it as we move through the original string. Got it. So we've got result hanging out, ready to be filled with properly spaced characters.
Right.
And of course, we've got our two pointers, string index and space index, both starting at 0.
Exactly. Now we begin our journey through enjoy your coffee.
All right.
The first character, E, is at position 0, which doesn't match our space index of 5.
So we add E to our result string and bump up string index to 1.
Right on. We do the same thing for N, J, O, and Y.
Yep.
Add them to result and increment string index each time.
Okay, I think I'm getting the hang of this.
Okay.
We keep chugging along, adding characters to result, until our string index lines up with a space index.
And that happens when we get to Y at position 5,
Right.
which matches our current space index.
It's space time. So we add a space to result,
Yes.
then the Y,
Right.
and increment both pointers.
Exactly. String index moves to 6, pointing to O,
Right.
and space index moves to 1, pointing to 9 in our spaces array.
Okay.
Then we add O, U, R, and C to result, since none of their positions match 9.
And when we get to O at position 9,
Yes.
we know what to do. Add a space, then the O, and bump up both pointers.
We've conquered all the spaces.
Right.
Now we just add the remaining characters F, F, E, and E to our result string.
And there you have it.
Huh?
Result now proudly displays, enjoy your coffee, all thanks to the two-pointer method.
I'm really starting to see the elegance of the two-pointer approach.
It's like a perfectly choreographed dance between the indices and the characters.
It really is. Now, are you ready to venture into the more hands-on approach with character arrays?
Bring it on. I'm feeling brave.
All right. First things first, we need to create our character array.
Okay.
Let's call it result array.
Okay.
And make sure it's big enough for our final spaced out string.
So same as before, we need a size of 1715 for the original characters, plus 2 for the spaces.
Exactly. Next up, we need our trusty space index starting at 0 to point to that first space at index 5.
Okay, space index is ready to go.
Now, since we're working with a character array this time, we need another variable to keep track of where we are in the result array as we're building it up.
Right.
Let's call this one result index, and we'll also start it at 0.
Got it. So result index is our guide through the result array.
Precisely. Now we can start looping through enjoy your coffee.
Right.
The first character is E at position 0.
Okay.
We compare this to the value at space index, which is 5.
Right.
They don't match, so we copy E into our result array at position 0, which is where result index is pointing.
Perfect.
Yeah.
And we increment result index to 1, so it's ready for the next character.
We do the same for N, J, O, N, Y.
Yep.
Copy them over to result array and bump up result index each time.
It's like we're carefully placing each character into its new home in result array.
Exactly. But when we get to Y at position 5, things change up a bit.
Because 5 matches our current space index.
Right.
So instead of copying Y directly, we first add a space to result array at position 5, where result index is pointed. Then we increment both space index and result index. Space index now points to 9, and result index is 6, ready for the next character.
Okay, I'm starting to see how this works.
Yeah.
We're essentially weaving the spaces and characters together in result array.
You got it. We keep copying characters until we hit position 9, where we need to add another space.
Right.
So we add a space at position 10 in result array, since result index is 10, then bump up both space index and result index.
We've handled all the spaces.
Right.
Now it's just a matter of copying the rest of the characters into result array F, F, E, and E.
And voila, we've constructed our beautifully spaced enjoy your coffee directly within result array.
It's like we performed character-level surgery on that string.
I love that analogy. And of course, the final step is to convert that character array back into a regular string using a string constructor.
We did it.
We conquered the character array approach.
It's definitely the most hands-on method, but it also gives you a lot of control.
I'm really starting to appreciate the nuances of each approach.
Yep.
String builders are great for their efficiency and ease of use. The two-pointer method is elegant for navigating multiple things at once, and character arrays give you that fine-grained control.
Exactly. There's no one best approach. It really depends on the specific situation and what you're trying to achieve.
I feel like I've leveled up my string manipulation skills today.
Absolutely. And that's what AI.Code.Cast is all about.
Right.
Stretching those coding muscles and exploring different ways to approach problems.
Yeah, sometimes the most basic-sounding tasks have the most to teach us about efficiency and elegant coding.
Exactly. Who knew adding a few spaces could be so insightful?
It just goes to show that there's always more to learn and new ways to optimize our code.
For sure.
So for our listeners out there,
Yeah.
if you're ever facing a coding challenge, just remember to think about those different approaches.
Yeah, don't just jump into the first thing that comes to mind.
Right,
Take a step back.
right.
Consider the tools and techniques at your disposal.
Could a string builder make things cleaner?
Right.
Would two pointers help you navigate the data more efficiently?
Yeah.
Or do you need that fine-grained control of character arrays?
Exactly.
Yeah.
Experiment, explore, and find the approach that's the best fit for the problem at hand.
And remember, the AI.Code.Cast community is a fantastic resource.
Absolutely.
If you're ever stuck
Yeah.
or just want to bounce ideas around, don't hesitate to reach out.
Absolutely. We're all in this together.
Yeah.
Learning, growing, and conquering those coding challenges.
One space at a time.
One space at a time.
So keep those coding brains buzzing.
Right.
And we'll catch you back here tomorrow for another deep dive into the world of code.
Until then, happy coding.